Friday Bytes by Helixz.
Hi everyone, today I will be working you through the critical landscape of modern identity and access management, also known as IAM. This presentation will explore how we manage digital identities and secure access in today's complex environment. What is identity and access management? To start, exactly is IAM? At its core, it is a framework of policies and technologies to ensure that right people have the appropriate access to the technology resources. We can break down into four key pillars. First one, identity. This is about establishing who a user is. Authentication. This is the process of verifying the identity, proving you are who you say you are. Authorization. Once verified, what are you allowed to do? This pillar defines your specific permissions and rights. Finally, provisioning. This involves the management of identities through the life cycle, including creating, maintaining, and deleting events. Example, you likely interact with the IAM system every day. Industry-leading examples include platforms like Azure AD, Okta, and Google, which provide the infrastructure for managing these identities seamlessly. Traditional authentication problems. Before we look at the modern solutions, we must understand the failure of the traditional authentication. There are four primary points. User maintain multiple passwords. Users are often forced to maintain different passwords for every system they use, leading password fatigue. Security inconsistency. Security policies often differ across various systems, creating weak links in organizational chain. Manual administration. Administrators are often stuck manually creating and deleting accounts, which is inefficient and prone to human error. Open accounts. This leads to high risk of open account. Active account belongs to former employee or contractor that remain accessible, causing massive security threat. What is a modern solution? What is SSO? This brings us to single sign-on. SSO acts as an intermediary between users and service provider, allowing the user log in once and gain access to all their permitted applications without recreating credentials. SSO protocols to make. Okay, let's see how SAML works. Step 1, the trigger. User navigate to the service provider and enter their identifier. The challenge. The service provider realizes a federated session is required. It generates the SAML authentication request and sends to the browser. The handoff. The browser automatically forwards the SAML authentication request to the specific identity provider URL provided by service provider. The identity check. The identity provider passes the SAML authentication request. It validates that request came from legitimate service provider, then serve a login page to the user. Submission. The user enter their username, password and potentially multi-factor authentication tokens. The golden ticket. Once IDP has satisfied the credential, it generates SAML authentication. It generates SAML assertion. SAML assertion contains the user identity, attribute, and digital signature. Closing the loop. The browser forces the signed SAML assertion back to the service provider assertion consumer service. The trust verification. Upon receiving the assertion, the service provider does not just take the user's words for it. It validates digital signature against the public certificate as on file for the identity provider. Core mechanism summary. Service provider initiate. The flow typically starts at the application, not the identity provider. Browser as transport. The heavy lifting of data transport is done by the user agent. The service provider and identity provider never communicate directly, server to server in this flow. Trust via signatures. Security relies entirely on SP trusting the IDP's digital signature on the some XML assertion. Okay, let's see how OpenID Connect works. First, user log into the service provider and service provider redirect with the identity provider. Then identity provider check this user already logged in. If it's not, and send login form to the user. Once fill the login form, user is redirect to the identity provider and validate credential. Then identity provider send authorization code via browser to service provider. Then exchange authentication code for ID token and access token. Service provider exchange authentication code for ID token and access token. Then identity provider give access ID token and access token to the service provider. Then issuer with ID token and access token Slack verify when service provider verify ID token and create the user session. Okay. Now we'll see what is scheme, a system for cross-domain identity management. In a traditional system, admin has manually create and delete account in every time someone join or left company. The scheme automates the provisioning process. When the employee is added to the central system, like identity provider like Okta, Azure AD, and automatically create their account in all other apps. When employee leave the company, scheme ensure their access is revoked the whole platform, instantly eliminating the high risks of open accounts. Okay. Let's see how passkey is work. First, account creation. The device generates two key pair. First one is access private key and public key. Then public key sent to the server and server store the public key. When authentication, server generates the challenge and device receive the challenge and verify unlock using Face ID or PIN and sign challenges with private token and send back to the server. Then server verify the signature using device public key and verify this user. SSO and scheme. Why they are better together? When you combine SSO and scheme, you create secure and efficient environment. Automated onboarding. Scheme create the account and SSO provides the security doorway to the entire instance of body. This is most critical benefit. The employee leaves, the admin deactivate them in central system. Scheme immediately tell all others to delete or disable that account. SSO ensure the user can no longer log anywhere. The eliminating open accounts together they prevent the high risk of open accounts which are active account left behind the former employees that can be exploited by attackers. Thank you.